Okay, so the last video we left off on, I showed you how to convert all these to decimals to figure out the right answer. I'm also going to show you how to simplify this into its most simplified form with pi. All right, so the first thing we're going to do, we're going to look at this, and I'm going to leave pi where it is, but I'm going to actually evaluate the rest of this formula. So I'm going to do rest of this equation. 9 squared times 285. So see how I just did these other two pieces? So that's going to give me pi times 23,085. So basically 9 squared times 285 gives me 23,085. And I'll put the 360 underneath it. Now, you don't see any of these answer choices with that fraction, right? Because it's simplified. So looking at it, I see two different denominators. I see a denominator of 4 and a denominator of 8. So we can easily see how to simplify this fraction using one of those two denominators. So 23,085 divided by 360. So we're either using 8 or 4. So let's start off with 4. 360 divided by 4 would give me 90. So let's simplify this fraction by dividing the top and the bottom of the fraction by 90 to see what we get. 23,085 divided by 90. Oh, it's going to give me a decimal, 256.5. That doesn't work. So A is not my answer, right? If I divided it by 90 and it gave me 57, then A would be my answer, but that does not work. So let's simplify this fraction using the other denominator we have listed, which is 8. So what I'm going to do is 360 divided by 8. All right, and it gives us 45. So what we're going to do is divide both the numerator and the denominator by 45. So we know 360 divided by 45 gives me 8, right? That's what we just found out. Now on the top, we'll do 23,085 divided by 45 gives us 513. So our fraction actually reduces to 513 pi over 8, which is answer choice D. So all we did was we put these numbers in the calculator and reduced the fraction using our answer choices. All right, so next up, I want you to pause the video and try the next problem. Once you're done, come back. All right, I hope you all attempted this problem. A cylinder has a radius of 10 centimeters and a height of 9. A cone has a radius of 10 and a height of 9. Show that the volume of the cylinder is 3 times the volume of the cone. All right, so we have a cylinder with a radius of 10 and a height of 9, and then we have a cone with a radius of 10 and a height of 9. All right, so I'm going to go back to the Big Ideas formula sheet number 2 and get our cone and our cylinder. So our cylinder is going to be the first formula, V equals pi r squared h. V equals pi r squared h for the cylinder. And for the cone, it's going to be 1/3 pi r squared h. So automatically, just looking at the formulas, you can tell that the cylinder is going to be 3 times as much as the cone because it's the same exact formula, just the cone has this divided by 3 piece of it. All right, so let's go ahead and evaluate it. We said this was the cylinder and this was the cone. All right, so this is going to be pi 10 squared 9, and this is going to be 1/3 pi 10 squared 9. All right, we don't even need the calculator for this. We can do this looking at it and using our heads. So 10 times 10, 10 squared is 100, and 100 times 9 gives me 900 pi. Don't forget the pi, right? The pi is part of the answer. All right, next up, 10 squared is 100. 100 times 9 is 900. And 900 divided by 3 is going to give me 300. You could also do 900 times 1/3, and I'll show you how that comes out to be the same. So you could do 900 divided by 3, and that gives you 300. Alternatively, we could do 900 times 1/3, and it gives you the same thing as 300. All right, so here are two answers for the cone and the cylinder. The volume of the cylinder is 3 times the volume of the cone, because 300 pi times 3 is equal to 900 pi. All right. Last question for this unit. Go ahead and pause the video and attempt the next question on your own, and then come back when you're ready. All right. Cylinder A and cylinder B are shown below. What is the volume of each cylinder? All right, so looking at this, our cylinder formula is pi r squared h. So the two things we need are r and h. So for cylinder A, my radius, I'm tempted to put 10, but it's not 10. 10 is the entire diameter. The radius is half of that. So my radius would be 5 meters. And my height is 12 meters. All right, cylinder B, again, they give us the diameter of 10, so we need to divide that by 2. So my radius would be 5 meters, and my height would be 12 meters. If you look, we have the same exact dimensions for both cylinders. So will they have the same volume? If you remember Cavallari's principle, it says if we have two figures that are not exactly shaped the same, but they have the same height and the same cross-sectional area, then they'll have the same volume. Now, I know that each of these is the same cross-sectional area because the circle base is going to be the same for each circle, right? You have a radius of 5, therefore both of the circles created by every cross-sectional area will have the same area. But let's go ahead and prove it out, even though we could have used Cavallari's theorem at this point. All right, so this is cylinder A. V is equal to pi, our radius is 5, squared times 12, and cylinder B. V is equal to pi times 5 squared times 12. All right, we're going to write our answer choice in simplified terms of pi and as a decimal, just so I can show us how we do it. Remember to simplify in terms of pi. Let's multiply everything together except for the pi. So I'll do 5 squared times 12. So this is going to give me 300 pi. If I put 300 pi in, it'll give me a decimal. So I'll say the volume is approximately 942.48. And remember, our unit here is meters cubed because we're talking about volume, and volume is 3-dimensional. All right, let's do the same for cylinder B. Again, I would put in exactly the same thing, right, because it's the same numbers. So volume is going to equal 300 pi meters cubed, and it's going to be approximately 942.48 meters cubed. So you can see they have the exact same volume, and we know that was true already using Cavallari's principle. All right, you are ready for your IXL assignments if you're in Miss Lucas's or Miss Moreland's class, or you can get caught up on your Khan Academy assignments if you're in Miss Strickland's class. Don't forget about the exit ticket on Illuminate or Google Classroom.